Oh, hey, good afternoon. Okay, let's start. I do not have these online yet. I'm running a little behind. This weekend was rather interesting, so I wasn't able to get to this. But I'll have things up by tomorrow. And what we'll talk about is a little more detail about the inheritance or the ISA relationship, and go through some of the code examples. And then what we'll talk about is basically the process of going through object-oriented design, moving into unified modeling language, and also development of requirements and test cases. And so that'll be today and Wednesday's discussion. And then we'll talk about that even more on Friday when we do the project discussion. So here are the outcomes. And as usual, go back after the week, convince yourself that you have these things. Okay, going back into the ISA relationship, inheritance. Remember, we have the two biggies are HASA, one object contains another, and ISA, one object extends another, or there's an inheritance relation between the two, this parent-child relationship. Okay, let's talk about overloading and polymorphism for a little bit. Overloading is where you create multiple versions of a method with different signatures. Now remember, what the signature is, the name with the input parameter list. You cannot, in the same method, create the same signature in the same class, but you can create a method with the same name as long as it has different input parameter lists. So for example, in the code, I've added these methods inside of circle shape. So we have public circle shape with no input, public circle shape with one input, and I use that to set the radius, public circle shape with two inputs, and I use that to set the X and Y locations. Usually, this is done when you're creating your own constructors for a class, and that's the first time we brought this up in the course. As you know, when you use the new keyword, that means you're creating a new object. And when you use the new keyword, the method that's called is called a constructor because it constructs an object of that class. And you get that for free. You do not have to define that method. The Java system will create that method for you. But you can actually create your own constructors. So in this case, I took the circle shape class, this is from the code that I sent last week with the previous module, module 5. And I've added these different constructors. And that's typically where you're going to use this. So you can create your own constructors. Now, when will you do this? Most likely you're going to do it when we get into the graphics things, most likely. Now, in the first situation, I said radius is equal to 0.0. I didn't have to put anything in there. What happens to, let's see, it has a radius, but it also has an X location and a Y location. We'll talk about that in a minute. What happens to the X location and the Y location? Well, those both remain having their default values. So you don't have to set a value for every attribute in the class. The ones that you do not reference in your own customized constructor will remain with the default value that Java gives them upon construction. So doing this, same method name, but different parameters, is called overloading. The trick here, let me see if I can bring these up. The trick here is that the Java virtual machine can always distinguish. If you call circle shape with no input, the Java virtual machine knows that that is the only circle shape that you're calling. If you call it with one input, then the Java virtual machine knows that that's the specific method you're calling. And if you call it with two inputs, then the Java virtual machine knows that that's the one you're calling. If I did this, and created two of them, that should cause a problem. And the reason is if I ever called circle shape, the Java virtual machine wouldn't know if I wanted that one or if I wanted that one, the one on line 19 or the one on line 23. And we're not allowed to confuse the Java virtual machine. If I try to compile this, hopefully I'll get an error message. Error. Constructor circle shape is already defined in the class circle shape. So it's telling me that I'm redefining a method and I'm not allowed to do that. Okay, questions about overloading? The term overloading often gets compared to a term called polymorphism. Polymorphism, poly, many, morphism, shape, many shapes. And polymorphism is related to inheritance. Now, overloading is not necessarily related to inheritance. I'm just bringing it up because when people talk about polymorphism, they also tend to talk about overloading. So let's talk about this notion of inheritance a little bit more deeply with the idea of polymorphism. Both overloading and polymorphism are great terms to know. It's good to know the difference when you're doing your job interviews. Don't be shocked if you get a question that hinges on knowing the distinction between the two. Okay, so what is inheritance? And again, inheritance is when you have this is a relationship. So on this ridiculous example, I have phi, phi, fo, fum. Phi extends phi. What does that mean? It means that phi inherits all the methods and attributes that phi has. We are allowed to add to that. We are allowed to modify or overwrite the methods in phi, and that's typically what you will do. And it also means, though, since phi extends phi, phi is a phi. It's the is a relationship. I'll go through some more concrete examples in a little bit. So polymorphism, what is that about? That's about creating and referring to various versions of the class because of inheritance. So in the previous page here, I have phi, phi, fo, fum. Well, phi is a version of phi, and fo is a version of phi. Fum is a version of fo. Phi is a relationship. Phi is a phi. And fo is a phi, but since phi came from phi, fo is also a phi. You're probably not going to go more than one layer deep. I did it, what, 1, 2, 3 extensions there, so I went 3 layers deep. You're probably going to go 1 layer deep in your in your projects, but some of you might go 2. But the point is, we made different forms of the same thing. So in a more concrete case, I think phi, phi, fo, fum was a bad choice. In a more concrete case, I've got here this generic shape, and it's got X location, Y location, and it's got a name. That's all it's got for attributes. And then I say circle shape. Circle shape extends generic shape. Therefore, a couple things. Circle shape inherits for free the attributes and methods of the generic shape, but circle shape is a generic shape. Again, you can always think in terms of how we classify animals. Maybe go back to your science or biology class. You have vertebrates, Underneath that, you have mammals. Underneath that, you have dolphins. A dolphin is a mammal, but it goes further up the line. A dolphin is a vertebrate. So this notion of is going to become important in a minute. So polymorphism is about making those various forms. We can say a dolphin is a mammal and a tiger is a mammal and an elephant is a mammal. That's all true. They clearly have different shapes. Many shapes, polymorphism. So polymorphism is correctly applied to the class level. However, normally this is done by overriding methods. Normally you have the same attributes and methods, and you're overriding the methods to change the behavior. And I keep harping on this over and over when you guys are doing your projects. In order for you to have a valid case for inheritance, you must have a change in behavior that relies on you actually changing the methods. Because of that, polymorphism is also talked about at the method level, but it is more accurately referred to as a class distinction, not a method level distinction. Whereas overloading is absolutely about the methods. Overloading is about multiple kinds of methods in the same class having different signatures. Polymorphism is about having different children involved in the inheritance relationship from a same parent. Now, what's the advantage to doing this? Why? It sounds so confusing. There's a huge advantage in terms of code development and code maintenance. And the reason is, if you develop all the code that deals with these different classes, if you develop all that code dealing with the top level class, the parent, then all of the children will work within that class. And they do it because of the is a relationship. And I'll get back to the code to talk about that a little more in a minute. Okay. So, for example, I have my generic shape, and then I have a square shape that extends the generic shape, and a circle shape that extends generic shape, and a rectangle that extends generic shape. And notice, right now my rectangle is empty. And that's because it already has the attributes and methods inherited from the generic shape. Now we can add to these things. For example, in the circle shape, I went ahead and added a radius. And in the square shape, I added a side length. In the rectangle shape, I would add a length and a width parameter. You're allowed to add. Ideally, you want them to be as identical as possible. Not always possible. Okay. And then last week I went through and did this shape controller, and inside the shape controller I made some circles and I just played around with circles. And how many attributes does the shape controller have? It has none. How do you know that? In order for things to be an attribute, they have to be outside of every method in the class. They will come right after public class, whatever the name of your class is. They come right after that, and there's nothing there. I say public class shape controller, and then I immediately jump into main without declaring anything, so I don't have any attributes at all. Everybody in here, this circle 1, circle 2, they're all variables, not attributes. They're variables inside of the main method. This causes some problems. Let me show you a better way to go about this. So now I create this better shape controller, and inside better shape controller, right off the bat, public class better shape controller, and then I've got 3 lines of declarations. I declare 2 circles, 2 squares, and 1 rectangle. And these are now attributes. They're attributes because they do not exist. They were not declared inside of any methods. Now, what's the advantage of this? The advantage of this is any method I make inside of the better shape controller class Any method that I make has access to those attributes. And that means I don't have to do any work in the main method. I do all my work outside of the main method. And that's something I keep encouraging you to do. Do all your work outside the main method. Here, since I created circle 1 inside the main method, I cannot call an external method to do the work on circle 1. I can, you have to use some cheap tricks to do it. So instead, I would have to do all my work inside the main method. Now, why am I discouraging you from doing that? Well, you guys have all programmed in C and you've all programmed in MATLAB. And the way you programmed, that was the imperative or procedural paradigm. The way you programmed was you did basically top down. You do the first line of code and the next line of code and the next line of code. And yeah, I know you may have had function calls, but you basically did a top-down design. If you do all of your work in the main method, you're still doing top-down design. You're still doing the procedural method. You're just hiding it inside of the main method. And with that approach, since you're not using the object-oriented approach, the rest of your classes and objects become clunky things that you just have to put up with rather than actually useful tools. Remember, the object-oriented paradigm views programming as communication between a series of objects. So if you instead create these things as attributes, you can make your main method much cleaner. And instead of doing the work inside the main method, all the main method is going to do is call some other methods to do the work for it. This is helpful in terms of design, programming, and code maintenance when you have to update your code. I know I grew up prior to the object-oriented paradigm becoming popular, and I programmed a lot in Fortran. I did a little C programming, and when I first came to Java, I basically took my Fortran code and plunked it down into main and said, ta-da, I'm now an object-oriented programmer, and of course I wasn't. I was just still doing the imperative method. So here in Better Shape Controller, we create these things as attributes. And now look at what I'm doing. I'm going to come back to this me dot in just a second. Now what am I doing? Oh, I'm just calling methods. And if I'm naming the methods appropriately, it's really easy to tell what I'm doing. Build circles. Oh, I'm probably building circles. Build circles, build squares, display all the shape info, find the larger area, and find the larger area. So there's a couple things here just in terms of code clarity. By reading these names, you can see what's happening. But let's go back to this notion of the is-a relationship and polymorphism again. Here I do find larger area me.object1, me.object2, and in other words, it's two circle shapes. And here I do find larger area me.object1, me.object3, so that's a circle and a square, because that's what object 1 and object 3 are, circle and a square. If we did not have inheritance, I would have to program a find larger method for two circles, for a circle and a square, a circle and a rectangle. And then if I think, oh, 5 weeks from now, someone says, by the way, you needed triangles, I would have to build a triangle class, and then I'd have to build a find larger area for circle triangle class. And then I'd have to do it for square, 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 rectangle, square, triangle, and triangle, triangle. In other words, a whole bunch of different methods. However, if I do the find larger area at the parent level, generic shape, S1 and S2, generic shape. A circle is a generic shape. It's a child of the generic shape class. A square is a generic shape. A rectangle is a generic shape. So it doesn't matter what I put in here. Circles, squares, or rectangles, it will work. You can see how a couple things are going on here. One is a programmer, it takes a whole bunch of load off of you. You don't have to do all these, well, if this is a circle and this is a square, do that. If this is a circle and that's a circle, do that. None of that. It works. And again, in terms of helping you as a programmer and in terms of code maintenance, if 5 weeks from now someone says, hey, Garfield, you need a triangle, I can add a triangle class and I don't have to change this method. Triangle would extend generic shape and this method would still work. So remember what's happening with object-oriented design. Part of what we want to do is to enhance code understanding and kind of encapsulate the functionality of everything inside the object. So if I change one object, I don't have to change another. And that's what's happening here. I can create a triangle shape as a child of generic shape, and I don't have to change anything about this class. I just have to change the new triangle class. So you're even taking into account, you're preparing for things that you don't even know you might have to do later. So that is the advantage of the inheritance technique. And again, the term polymorphism is used because we literally have different shapes here. Square shape, circle shape, rectangle shape. We have many shapes, polymorphism. Now, the fact that these are actually truly geometric shapes is coincidental. Okay, now in order to do this technique though, I do have to do one thing. These methods that I created down here, and notice I still got them in my blank form, right? These methods that I created down here, I keep telling you don't make methods static. So they're not static, which means I cannot use them until I create an object of the class. If you have a method that is not static, you cannot attempt to use it until you create an object of that class. And this is the better shape controller class, so I need to create an object of the better shape controller class. So I do have to do one additional step here. I have to create an object of the better shape controller class. I do that right there inside of main, better shape controller me, probably a lousy name, equals new better shape controller. The new keyword tells you that we built a object of that class. Then I can say me.build circles, me.build squares, me.display all shape info. All of that stuff. So there's a little bit of a price to pay. Now it may seem odd that inside the better shape controller class, right, here I am inside the better shape controller class, I can create an object of the better shape controller class. And that is an odd thing to think about at first, but I recommend that you think of main as being external to all of the classes that you're dealing with. And if you just logically have that point of view that main is external to everything, then it makes sense. And quite frankly, main does act that way. It does act external. Main doesn't have access to those attributes because those attributes don't exist until you create an object of the class. It would be, if you wanted to talk directly to object one, it would be me.object1. But you should never do that, right? Because if main is external to the class and these attributes are private, that's technically breaking a rule. Okay, before I switch gears into another topic, do we have questions?
I have a quick one, and I don't know, maybe you answered it. But when you were in, I think circleshape.java.
Sure, let's take a look.
Why do you need that one where the radius is equal to 0? Because we had to do that on one of our assignments too, and that's like not a circle. So why do you do that?
I did it because once I start declaring alternative forms of constructors, the Java virtual machine wants me to give it a standard form also. And so I gave it a fairly useless standard form.
Okay.
Again, I'm doing a lot of stupid stuff on these examples because you're right. Why would I say radius equals 0.0? Right? It's not a circle. Technically, it is a circle, right? But it's not a very interesting circle.
Yeah.
Right?
Okay.
So it's just to do no harm while meeting the needs of the Java virtual machine.
Okay. Okay.
Okay. I think an interesting point would be to put a negative radius in there. Is that a circle? Then it depends on if you're dealing with some, you know, some of you guys are doing engineering physics, and you might have some really bizarre mathematical models for how quarks work or something where you need negative circles. I don't know. Okay, so let's switch gears now. That's the inheritance part of the talk. Now let's talk about code development. See, my notes are unclear. Code development, what we're going to talk about is unified modeling language, and on Wednesday we'll get into requirements and test. We've talked about requirements and tests a little bit before, but we'll talk about it more since you have homework due Friday, whose job is for you to come up with some requirements. Okay. So unified modeling language. Again, go back to the three main things we hope to get out of the object-oriented paradigm. The first was data encapsulation, protecting your data. That actually worked very well. The second thing was to get code reuse, the holy grail being that you literally could just take a chunk of Java code from here, there, and another place and just, you know, and them together and it would work. That does not work. By the way, if you want to Google component-based programming or component-based software design, go ahead. That's a community of people who are trying to make that work using software components that you stitch together. It is provably chaotic in the mathematical sense. So far that hasn't been too lucky. However, there has been huge success with code reuse using the inheritance relationship. So that's been very successful. The third goal of object-oriented programming was try to help to get a handle on software understanding. And software understanding is an intrinsically difficult problem. It's actually one of the things that helped drive the development of the object-oriented paradigm. It is remarkably difficult when you have anything other than a trivial software design to actually understand what's going on. And you'll hear, you know, anecdotes about people saying that in a real live production code, there are comments like, we don't know what this line of code does, but don't remove it because the code breaks when it does. Or you know, you'll hear the stories of the code doesn't work and we don't know why. The code does work and we don't know why. And it's an intrinsically difficult problem. And again, it's distinct from other forms of engineering, because other forms of engineering, you have a physical thing that you can hold in your hand and look at, and we're kind of built to understand things like that. It's harder for software design. So there have been multiple attempts, and this predates object-oriented programming, multiple attempts to try to improve software understanding. The whole programming language of Ada was built around trying to improve software understanding. The fact that you're not being taught Ada in college is teaching you how successful that attempt was. So this is an attempt to help improve software understanding. Unified modeling language was developed. Unified modeling language, even though it's called a language, it's technically a series of charts, a series of graphical depictions of software. And there are, I forget, 7 or 9 different kinds of charts, basically. We're only really going to talk about one of them, the class diagram. There are other diagrams. By the way, one of the most useful diagrams I've ever found is one where you follow the data through the different classes. That's a nice diagram, but we're not going to do that in this class. If you are someone who's going to take some additional SE courses, SE 300, you'll get a little bit into this, but when you get into the higher SE numbers, you know, 320 and those classes, you'll learn more about UML. It's quite a mature system. There is something called rational rows, where in theory, if you do all your UML diagrams correctly, it will auto-generate the Java code for you. How nice is that? It's not never correct, by the way, but it's a good attempt. But that's what this is about, trying to understand software. And so what we're going to do is start to show classes, and we're going to show the relationships between the classes, primarily the is and has a relationships. So first of all, you have to be able to do a single class. And the way you do a single class, and I'm doing the sheepdog example again, is you draw a box, and then you put inside the class name, and then you list all the attributes and you list all the methods. Not all the methods. And the way you list them is this. You start out with a plus sign or a minus sign. A plus means public and a minus means private, and I'm keeping all my attributes private. Then it's the name of the attribute, and then a colon, and then the attribute type. So I have a private attribute named X location, and its type is double. In code, let's see here. In code, oh, this is the generic shape. I've got these guys on the same line for the declaration. Perfectly fine, no problem at all. In your diagram, do not do that. Everybody gets their own line. And I just do that for each one. We'll talk about why I have these in a minute, but that's these. Then for the methods, I do the same trick. Plus public, move is the name with no input, nothing in between the parentheses, colon, void, why? Because that method does not return anything. So all you're going to do is list your attributes and methods, and you're going to, and that didn't work. You're going to give them the minus or the plus, and then you're going to do a colon, and then the type. So private int xvar becomes negative xvar colon int. Private double YLOC becomes negative YLOC double. Here's a method that has input. Private double foo int x becomes negative for private foo int x, the full signature, and then colon double. Why double? Because it returns a double. So it's a pretty straightforward process. Now, I am writing this as if I have code and I'm creating the diagram. You actually do the process backwards. Now, if you do your code and your code is different from your diagram, yes, you have to update your diagram, but you want to create the diagram first. Why would that be? Any thoughts? Let me ask it this way. Which would you rather do? Design something and build it, or build it and then have somebody design it for you?
Yeah, making this diagram helps you design.
Exactly. This is a design process, and we're engineers, right? You should design, then build. Otherwise, you have no clue if you built the right thing or not. Design, then build. So what you're doing is, this is actually a design exercise, and that's why you're going to deliver your UML diagrams in your P3 deliverable. Prior to doing any coding, you'll do your design. Now, that doesn't mean your design is locked in stone. As you start to do your code, you might find that you made some really lousy design choices, and that's called normal. That's part of the job. All right, so now once we have one of these things, how do we create the diagram that shows the relationship between the different classes? Well, UML uses these special symbols. Now, you will find some variations in these symbols, by the way, but these are the symbols we'll use in class. Remember, we're really going to focus on the has a relationship and the is a relationship. And the has a relation is a line with a diamond at one end, and the is a relationship is a line with an arrow at one end. And for the diamond, sometimes you have, for example, in that first example, class A has one or more of class B. That's the diamond, the open diamond, not filled in. And that means that you can, class A might have multiple Bs. Like in my better shape controller, I had 2 circles and 2 squares. You might have an array of Bs, an array of objects. Now, you don't necessarily know how many you have. If you do, you can list it. You can actually, if you know you have 5, put the number 5 on the B side of that diagram, but I'm not going to worry about that for this class. Sometimes you know you have exactly one of these things. For example, in the sheep-sheepdog game, I have 3 sheep and 1 dog. So that 1 dog would show up in the second form there, that middle form. You fill in the diamond is all. So that's saying that class A has exactly one of class B. And notice which end the diamond is on. I always have to check to remember. Class A, the one that contains the class, has the diamond. And then the is a relationship is the arrow, and the arrow goes from the child to the parent. So class B extends class A is the parent, class B is the child. And it's an arrow. You can find more variations than this. We don't need to worry about them for the class. And again, for homework 4 and for P3, I'm going to ask you to build these diagrams. And I must insist that you do not do handwritten diagrams. They look like crap. They're hard to grade. They're hard for you to edit as you're building out your design. Don't do that. You can build these things in PowerPoint fairly easily. There are tools out there that will build them for you. I'm not a fan. They tend, the tools that are out there that build them tend to build them from the code, which is putting the cart before the horse. But there are tools out there. There's also something called, I think Visio. Have any of you guys used Visio? It's a chart making tool online. Anyway, if you use something like that, just make sure that the format that it ends up in is compatible with what you need to turn in. So in P3, you actually need to turn in a document with your UML diagram inside the document. If it's external to the document, you get a 0 on the UML portion inside the document. So you have to be able to cut and paste it into a Word document. By the way, I'm speaking from experience, right? I've gotten lots and lots of deliverables with the UML diagram external. And sometimes I think it's a .io format, which I can't read, and sometimes handwritten, which I will not read. So when you put all this together, we've got the individual class, then we've got these connectors that show relationships between class, and it looks like this. So let's talk about this. This is the old sheep-sheepdog game, which I find is just a marvelous example for the course. Let's see, you start thinking this way. Okay, I've got the sheep-sheepdog game and I've got a visualization of what I want it to be. I want the user to be able to control the sheepdog in some fashion, and then I want the sheep to run away from the sheepdog in some fashion, and then I want the user to try to pen the sheep. So what do I need? And we talked about this early on in the semester. Okay, we need a class for sheep, clearly. We need a class for dog, clearly. We need a class for terrain, clearly. We need a class for pen, maybe. See, now we get into maybes. I'll need a class that actually just controls and runs the game. I'm going to call that my game manager. Oh, I'm going to change that to game controller. Okay. And then I need some GUI elements. So right now I'm not going to show the GUI elements, and I'm not going to ask you guys to show GUI elements because that's unfair. We haven't talked about how to make a GUI yet. Okay, then I start thinking some more. Okay, sheep and dog. Oh, what do they need? Oh, they need X location, Y location, movement. Blah, blah, blah. Oh gosh, they sound awfully similar. Maybe what I should do is have a generic animal class and then extend them. So I'll create my generic animal, and then sheep extends generic animal, dog extends generic animal. And that's what this is showing. I've got the generic animal class that I had before, And then this arrow is showing you that the sheep extends that class, and then the dog extends that class. That's showing you that. And then the game manager, oh, let's fix that now. The game controller has a dog. And since we only want one dog in the game, I'm going to fill in that diamond. The game controller also has sheep. And since there's more than one, I'm going to not fill in the diamond. Now, if I know I want 3 sheep, I could put a 3 here. If I wanted to. Okay? I don't have to. I'm not requiring that you guys do that. And then I've got terrain, and there's only one terrain. And so that's why that's filled in. Now I can choose to, the dog is a generic animal, I can choose to add attributes to the dog. I can choose to add methods to the dog. I will certainly overwrite the move method. That's really how the sheep and dog behave differently. Remember, when you're doing inheritance, the way to justify it is that you are modifying the move methods, meaning you are modifying the code in the move method. So the dog move method, the code will look completely different than the sheep. For the dog, I want the user to be able to interact and move the dog around at some point. And for the sheep, I just want them to run away from the dog. So I'm going to do this. Screws it all up, okay. To do that. So the sheep need to run away from the dog. Now, how am I going to get the sheep to run away from the dog? They have to know where the dog is. Now I've got a design decision, and I don't think there's one right answer, okay? I've got a design decision. Basically, the game controller knows where the sheep is, and it knows where the dog is. So what the game controller can do is constantly say, hey, dog, where are you? And then tell the sheep, each sheep at a time, one at a time, here's where the dog is. And that communication path would go through, right, okay, hey dog, where are you? I'm over here. And then this would tell the sheep, hey, here sheep, here's where the dog is. Why don't you move now? That's a perfectly legitimate way to do that. But I thought, I'm going to try something else. I'm going to let the sheep know where the dog are directly. And how can I do that? I can add a dog to the sheep class. So that sounds weird, doesn't it? Sheep has a dog? That sounds weird. But here's what we can do. If I build the dog, right, the game controller has a dog. So the game controller builds a dog class. And then, remember what the class name is. The variable name, attribute name is dog. Remember, that's just a handle to the memory space where the dog information is stored, including the dog methods and the dog attributes. It's just a handle. So why doesn't the game controller just pass that handle down to the sheep? Now the sheep has direct access to the dog information. So that's why I did it this way. I said, okay, let's let the sheep actually have a dog, and I'm going to have the game controller pass that handle down to the sheep. And now the sheep can always say, okay, I know I'm going to go find out where the dog is myself. And then I'm going to run away from the dog. And the same thing with terrain. We don't want the sheep to run off the field of play. We don't want the sheep to run off the terrain. So you ask yourself these questions, and these are tough questions, by the way. You ask tough questions like, gosh, should the game controller make sure the sheep never run off, or can we let the sheep be responsible for not running off? Can we write that in their move method where they'll never run off all by themselves? And if the sheep know where they are on the terrain and they know the shape of the terrain, then they can determine that themselves. So I'm going to go ahead and do the same trick. The game controller will create a terrain, and then it's going to pass that handle down to the sheep. Now the sheep have everything they need in order to do the movement. Now, I don't know if this is a wonderful design or a lousy design, but that's my design. Will it change? Almost certainly. You're not required to get it right the first time. All you need to do is have this good plan. And I'm going to talk about process, coding development process a lot more on Wednesday. And there is a little bit of chicken and an egg here. Because remember how I had you start out, you start out with your user stories and then you start attacking these user stories, which means that you're not really going to fill out your classes until you do the user stories. But on the other hand, unless you have at least some idea of what the classes should be and some good notional idea of what this is going to be, it's awfully hard to actually do individual class design and the overall software design and the actual coding. So I've created this design. Now, I'm asking you to do this in P3 before you do any actual coding. And again, the reason is you should always design something before you try to build it. Right? You always measure before you cut. So that's the goal here. Here's how many hours I think you're going to spend on each thing. I think your P3 is something like 8 to 12 hours. It's not trivial, and I think it's actually 12 hours. And this is why, one of the reasons why. You can and you should take a fair amount of time doing this. Don't just slap it down, oh shoot, I got to do UML diagram, and you just slap down these classes in 10 minutes. You probably could, but I guarantee that you won't enjoy your programming that you're going to do later on in the semester nearly as much as if you actually do the heavy work now of creating this design. And that's the goal. You try to get as complete a design as you want here. You may not be right on every detail, and that's okay. You're going to be right for most of it. Now, how does this help you do your software when you're actually programming, actually coding? Oh, now you go to your user stories and, well, I'm sorry, before that. It helps because I can take this, you could do this. You could take this document that you're looking at right now, and you can create all these classes right now. All of the methods that exist in this class would be empty. And also, it would make you realize some things. Like I probably am missing some methods here in the game controller class. There probably should be some methods built, right? Oddly enough, main won't be in there. It'll be up in the GUI. So it'll help you think through this stuff, but it'll also give you basically what I'm calling a working framework. If you have all of your classes already existing with these move methods that are empty, do it like I did here, right? I've got a calculate area. Oh, it didn't really calculate the area, but it's a method that can be called. Then you say, okay, now I'm going to do my user story number 1 and number 2. In order to do that, I only have to change one method, maybe. Maybe the first thing I would attack here is I would give them the dog move method. I would actually flesh out the dog move method. And then I could test that. But the fact that I'm just doing the dog move method, I know I'm going to let you go in a second. The fact that I'm just focusing on the dog move method really helps me as a programmer. I'm not going to get distracted with, oh crap, I forgot to do something in generic animal. Oh crap, I forgot to do something in game controller. Nope, I'm doing the move method. And I will only touch other classes if I absolutely have to make that move method work. And I'm sure you guys have experienced this when you have been programming before. You're down here in one part of your code and you're starting to modify it, and then you're like, uh-oh, now I've got to go change this and this and this and this and this, and change things all over the place. This is a huge advantage of the object-oriented system, is you don't have to do that. If you design these things clearly up front and you have all this separation of functionality where everything is contained in their classes, then as you go through your user stories and say, okay, now I want to make this happen, okay, I have to change a method in this class and a method in that class, and that's it. And it helps you be more efficient in your coding. Okay, I will reiterate this on Wednesday, and we'll talk about the process and talk about testing and requirements. And I'm a little over time, so I'm gonna let you go.
A quick question, if you could.
Sure.
P2, do you have a filled out example of the agile tracking?
Yes, it's in the zipped up files that I sent you.
Oh, okay. I had looked through.
Assignment.
It's in zipped files located.
Right.
Okay, I'll search for them. Thank you.
Okay,
Have a
sure.
good.
If you can't find it, send me a Canvas message note.
Yes, sir. Will do.
All right. Good day. Bye.